Hello all, this is Farhana. Welcome to my channel. In this video, I'm going to find out if AI can help achieve environmental sustainability. During the past few years, we keep coming across headlines that alert us how artificial intelligence AI will take over our jobs and that robots will rule the world. However, in the sea of all this information, we can also have encounter the positive impacts of AI helping us make the world a better place. In the global attempts of achieving sustainability and more notably meeting the UN Sustainable Development Goals (SDGs), AI can become a powerful weapon towards circular economy and more sustainable living. With AI undeniable rising popularity, it will be applied to all the industries and will be leveraged for a variety of causes such as environmental sustainability. As the field of AI continues to thrive, companies with massive ecological impressions can leverage the field's power to make serious changes to our world as we know it. If anything, right now is a historic time in artificial intelligence. With advancement in big data, hardware, and emerging powerful AI algorithm, it seems like all the pieces are coming together to make huge changes to our everyday lives. Saving planet Earth does not seem as hard as it used to be because of these advancements. What is sustainability in digital technology? Digital technology and digital sustainability is the process of applying social, economic, and environmental stewardship principle to digital products, services, and data delivered via the internet. Designers and developers might interpret this as a call to deliver more resources efficient digital products, and they would be right. Citizens, business, and policymakers are all facing enormous tasks. Green transformation will require business to develop new sustainable infrastructures, economic systems, and value creation networks. Policymakers will have to create conducive political framework, conditions, and incentive. Finally, everyone will have to work together to transform our socio-cultural playing field. In practice, this means digitalization must be carried out in a way that has positive effect on sustainability. We cannot allow digitalization effort to reinforce unsustainable behaviors, patterns, or economic practices that damage the environment and exacerbate the current environment crisis. Digital transformation itself, that is, its technologies, infrastructure, and business model, must be sustainable by design, and the environmental impact of digitalization must be minimized. Digitization is the translation of information from the physical world into electronic signals. It is a prerequisite for digitalization and fundamentally enables the decoupling of information from the limitation of time and space, thus giving unlimited information usability. This digital mapping of the world is becoming increasingly accurate under Industry 4.0. For example, digital twins for plants and processes enable comprehensive optimization within virtual environment. In addition, information availability is now the basis for new sustainable services such as in local sharing or repair economics. Digitalization is characterized by extremely dynamic innovation, especially in the key technologies such as sensor technologies, data transmission, and chip technologies, as well as in certain types of data analysis such as artificial intelligence processes. Technological progress is rapidly changing the way data is collected, connected, shared, analyzed, and used for decision making and interventions in the physical world. Now applications are constantly emerging and the scope of these applications is ever expanding. Digital technologies and the applications are critical to green transformation since they are capable of radically changing the way we organize work, production processes, human behaviors, and business model. These radical changes are where the greatest opportunities lie, and so we must seize them while we can. Over the next few years, society will have to create conditions that enable us to organize our lives and economies within the framework of the Sustainable Development Goals. Achieving this will require a fundamental change of direction in all key areas of action across all sectors. For structure, we refer to the transformation arenas: energy, resource and water management, mobility, consumption, city management, agriculture, nutrition, education, and health. These sectors are all currently waiting on comprehensive system transformation in terms of political framework, incentive systems, market structure, infrastructure, value chains, and behaviors. AI has become an important area to tackle most environmental sustainability issues such as biodiversity, energy, transportation, and water management. Biodiversity research has developed machine learning or natural language processing solutions to predict ecosystem services. Artificial intelligence applications and machine learning models have been increasingly used for predicting and optimizing water resource conservation. Area neural network, expert system, pattern recognition, and fuzzy logic models are a main focus area in energy. Applications of computer vision and decision support were found in transportation. Timely monitoring of interventions is required to improve environmental sustainability. Addressing environmental sustainability challenge is complex, but with the introduction of AI, most of the common environmental problems become simple to address by putting the interest of the people in action. The environmental, economy, and society are interrelated dimensions of sustainability, where sustainability, according to the UN documented title, Our Common Future, also referred to as Brundtland Report, defines sustainability as sustainable development and sustainable development as development that meets the need of the present without compromising the ability of future generations to meet their own needs. Environmental sustainability, as defined simply as meeting both the resource and service needs of present and future generations, where the health of the ecosystem is not compromised for humanity. Artificial intelligence refers to the ability of any machine or computer to mimic human capabilities, such as learning from examples and experience, recognizing objects, understanding and responding to languages, making decisions, and solving problems. Combining these different capabilities, the machine can perform complex functions such as driving a car. AI has gained popularity due to its successful development in applications that were once unthinkable. For instance, talking to Siri or Alexa to set up your calendar. Here are some illustrative examples of how companies using AI to be more in line with a sustainable future. For example, Google uses an AI model to reduce the energy load of its resource-hungry data centers, reducing the energy cost of cooling by 40%. IBM is using AI for better weather forecasting, making their predictions 30% more accurate. This helps renewable energy companies to better manage their plants, maximizing renewable energy productions and reducing carbon emissions. Excel Energy, a coal-burning and nitrous oxide emitting consumption patterns, and adopt its operating system, thus significantly boosting efficiency of around 20%. Carbon Tracker, a climate advocacy think tank, uses AI to track emission from coal plant using satellite imagery. Using satellite data, they help guide investments towards lower footprint ventures. Leading companies understand that achieving ambitious sustainability goals require a systematic approach to transformation, one that takes a 360-degree view of the challenge. Building sustainability as a competitive advantage, however, requires integrating technology and data from the very beginning. The role of tech goes well beyond green IT, as more companies think about their technology and sustainability agendas in concert. Management teams should ask whether they are bringing game-changing technology and digital thinking to the task of meeting sustainability goals, or whether this critical business issue is missing an important dimensions. The technology eco advantage. For companies willing to think broadly about how to advance their sustainability initiatives, technology can act as a major accelerant. We call this mindset technology eco advantage, using advanced technologies and ways of working to enable profitable solutions that also have a positive impact on net zero and other environmental, social, and government goals. Take the example of achieving net zero GHG emission. Our experience shows that for an organization of about 80,000 people, the combination of process automation, carbon data transparency, circular products or service design, and sustainable business models can reduce emission by 45% to 70%. What are the tech accelerators to advance sustainability goals? Digitized operations. Frontrunners in this area create inherently more sustainable operations and processes. For example, new manufacturing or material technologies that leverage alternative inputs to reduce emissions and waste and win consumer and investor rewards as a result. Digitized operation also can improve business resilience. Some of the processor and technology involved even become industrial standards. Chandler Electronic transform itself from an installer of industrial electronic equipment to a global leader in efficiency as a service, generating revenues from reducing customers' CO2 emission. The greater the environment and social impact that Chandler creates through energy saving and emission reductions, the more it's financially rewarded by customers and the faster its business expands. Digital products and services. Leading companies create new distribution channels that break economic constraints to expand reach, scale, and access for beneficial societal impact and affordable cost. Apps that digitize and facilitate access to essential goods and services are one example. A major city transportation authority designed three customer centric sustainability solutions that reimagined how parcels are delivered while reducing emissions, transforming the customer experience, and delivering sustainable growth and profit. Cloud IoT and blockchain. Advanced digital technologies and tools such as connected IoT sensor and monitors, cloud-based data platforms, and blockchain-enabled tracking systems unlock new capabilities for the measurement and tracking of environment and social impact across value chains. Companies, in turn, can better improve management and investment decisions and improve their performance against ESG goals. For example, value chain transparency solution that use blockchain technology guarantees the integrity and safety of products from supply source to producer to retailer to consumer. AI and advanced analytics. These technologies generate data and insights on the environmental and social impact of a product, services, or process. Digital platform integrate capabilities, share data, and create transparency and accountability among partners. Frontrunner leverage these capabilities to develop and fine-tune offering, engage customers, and improve performance over time. IoT and AI-based solutions also optimize energy efficiencies in real time, reducing emission and saving money all at once. Data sharing and ecosystems. Data sharing enables new models of collaboration within or across industries or sectors to develop novel solutions to environmental and social issues. Companies can more easily pool resources, fill capability gaps, access new markets, and expand reach. For example, software platform that integrates insurance underwriters and telecommunication providers can deliver micro insurance via phone subscription to underserved population. BCG researches into the impact of data sharing on big social challenges has shown that data sharing generates value in 5 ways: enabling innovations, creating trust, facilitating coordination, raising awareness, and validation hypothesis. Fertilizer producer Yara for example, is developing a new business unit to become an IoT and digitally enabled smart agriculture leader that improves sustainability by reducing the need for chemical fertilizers by up to 90%. New science based on data, the company collects informed the development of next generation regenerative crop nutrition solutions. Taking an early technology-led approach, in 2020, BCG examined 300 corporate sustainability initiatives. Of those, 85 were cases of sustainable business model innovation that generated both social and business value. Half of these companies used innovations in products or processes or changes to the value chain to mitigate negative environmental impact. Another 25% reimagined value chains and business ecosystem, attempting to address the root cause of environmental and social needs. The top 25% successfully reimagined their business entirely, reshaping the boundaries of competition to address the root causes at scale for growth and advantage. A key differentiator for those front-runner companies was using digital capabilities and technologies to break economic constraints and unlock new solutions. But success depends on leveraging technology and data from the very start. Before making a major commitment of time, management, energy, and company resources, management should take a forward looking and strategic view of how advanced technology and data can accelerate the journey to sustainability advantage. We can't manage what we don't measure. Uh, this rings true more than ever today as the world faces a triple planetary crisis of climate change, nature and biodiversity loss, pollution, and waste. More climate data is available than ever before, but how that data is accessed, interpreted, and acted on is crucial to managing these crises. One technology that is central to this is artificial intelligence. AI can play a role in tackling environmental challenges, from designing more energy efficient building to monitor deforestation to optimizing renewable energy deployment. As this is a snapshot of real-time analysis from Microsoft that is leveraging AI's capability to analyze complex multi-phase data sets that monitor and mitigate methane emission over the passage of time. Reducing the energy sector's methane emission is one of the quickest, most feasible, and cost effective ways to limit the impact of climate warming, and reliable data driven actions will play a big role in achieving these reductions. It can help calculate the footprint of products across their full life cycle and supply chains and enable business and consumers to make the most informed and effective decision. What are the key challenges in applying AI for environmental sustainability? It has been established that artificial intelligence addresses environmental challenges, sustainability, but on the other hand, they are challenged on the basis of relying on historical data and machine learning. This is due to the unpredictable and evolving nature of artificial intelligence because the variability of the human behavior is difficult to incorporate into machine learning model. Thus, past data before any extensive human activity reflect ages and climate cycles, and thus estimating potential climate change is difficult. Also, managing variance where past data is fitted into model, as most machine learning practitioners have special attentions for them. New data associated with these models can be generalized, and this is a recipe for inaccurately predicting future scenarios, which is technically known as variance bias trade-offs. Also, increasing risk of cybersecurity is a challenge in applying AI for environmental sustainability. Cybersecurity risk management is important in data integration for AI applications. However, the rising level of cybersecurity threats as a result of hacking is a major challenge to address environmental sustainability challenges because third parties gain access to critical data and siloed approaches are less effective in minimizing cybersecurity risk. Inaccurate and inadequate measurement of performance and certain human behaviors answers to various interventions based on AI support is another challenge in applying AI for environmental sustainability. Measurement and monitoring of interventions are critical in advancing environmental sustainability. The measurement is complex and often unsuccessful, and as such, combining both technical and analytical performance in a holistic metric loads to the success of AI for environmental sustainability. AI applications are as intelligent as human for decision making, but its focus is quite different in terms of human responses to decision. However, it is critical to understand the behavior responses while evading the common problem known to be associated with the advancement of technology as a result of the trap of the rebound effects. In the end, I asked the same question to our friend ChatGPT. Can I help achieve environmental sustainability? And here is the answer. Can I help achieve environmental sustainability? And here is the answer. Yes, AI can help achieve environmental sustainability in various ways. For example, AI can be used to optimize energy consumption in building and industrial processes, reduce waste, and improving resource efficiency. AI can also be used to monitor and manage environmental systems such as forests, oceans, and air quality. Additionally, AI can be used to analyze large data sets to identify patterns and trends that can inform policy and decision making related to environmental sustainability. And then I asked, can you give me some examples? And here's the response. Certainly, here are a few specific examples of how AI can be used to achieve environmental sustainability. Energy efficiency. AI-powered building management system can optimize heating, cooling, and lighting to reduce energy consumption. Additionally, AI algorithm can be used to predict and prevent equipment failure in industrial processes, reducing downtime and energy consumption. Renewable energy. AI algorithm can be used to predict and optimize the output of renewable energy sources such as wind and solar power. This can help to increase the effectiveness and efficiency of these energy resources. Resource efficiency. AI-powered system can be used to optimize the use of resources such as waste and material in industrial processes. This helps to reduce waste and increase efficiency. Environmental monitoring. AI algorithm can be used to process and analyze large amount of data from sensors and cameras to monitor environmental systems such as forests, oceans, and air quality. This can help to identify areas of concern and inform conservation and management efforts. Climate change. AI can be used to evaluate the impact of different policies and practices on the environment, such as how much greenhouse gas emission will be generated. It can also be used to predict future weather patterns and other climate-related phenomena, which can inform decision-making related to climate change adoption and mitigation. Sustainable transportation. AI can be used to optimize traffic flow and reduce congestion, which can reduce emission from vehicles. Additionally, AI-powered self-driving cars and drones can be used to make transportation more efficient and reduce the need for fossil fuel. These are just a few examples of how AI can be used to achieve environmental sustainability, and research in this area is ongoing. Thank you for watching.